So for Module 5 of Lecture 4, we'll look at the basics of conditional statements, and we'll talk about the syntax for an if statement within MATLAB. So conditional statements are what really make the behavior of software interesting. Up until now, when we put a bunch of commands in MATLAB within a script, the interpreter just executes those commands sequentially in the order that we've entered them. So the software will behave the same way every time, absent of any random number generations, if we were to continuously execute the script. However, when we think about the applications that we interact with on a daily basis using computers, one of the things that makes them work in an interesting fashion is that they don't run the same way every time. And the basic structure that allows us to do that is known as a conditional statement. So conditional statements, as I put formally here in the first bullet point, really just allow you to implement decisions within software. So you will behave differently or execute different code blocks depending upon the settings of a logical variable. And we typically represent the execution structure of a program that has conditional execution using these program flow diagrams. And we're not going to worry too much about this since this is a programming for engineers course and not like a multi-sequence course in actual software development. And what happens is the structure of these that people use depends highly depending upon the textbook that you use. However, you usually, I'm guessing the majority of you can recognize how this works without me even explaining it to you. And there are some common aspects to them independent of style. Namely, just like in a flowchart, when you see a diamond, that's usually where your decision is being made. That's where the so-called branching in the program occurs. In addition, the arrows kind of tell you the direction that you move in the software flow. So notice that after this branching decision node A, if the outcome of that logical variable or decision is true, you will execute code block B. If it's false, you will execute code block C. And in general, these black dots are used to indicate either the start or stop point, and you can kind of indicate which one is which depending upon the direction of the arrows of the little code block. And oftentimes these aren't used to represent, they're in addition to representing the flow of an entire script or program, they can be used to implement like the flow of a very small portion of the program. And that, of course, would be in this case. And as we'll see in the next statement, this is the most fundamental example of what would be called an if-else statement, because we're executing two different code blocks kind of contingent upon the decision of A. So in MATLAB, the basic if statement has this syntax. We have the keywords if and n, which I bolded. We have the kind of identifier logic expression and the identifier code block. And all logic expression has to be is any statement that evaluates to a logical variable, either 0 or 1. And code block can be any kind of collection of MATLAB commands. It can be as long as you want. And what's going to happen, the way this will work as the interpreter moves through the execution, is if the logical value of logic expression is true, then code block will be executed. If it's false, then the interpreter will just skip directly to the end. So what this is, the most kind of simplistic form of the if syntax, is a way to execute one code block kind of conditionally, depending upon the value of logic expression. If you use the help function in MATLAB for the if keyword, you'll notice that you have an ability to generate an arbitrary number of code blocks conditionally. And you do that using what's known as the else if and else example. I should say keywords there, sorry, not example. Jumping ahead of myself. So if I type if else, you will notice that I can put as many else ifs as I want here in the middle of my syntax. And what that's going to allow me to do is if I have multiple things that I want to execute conditionally, I will be able to define multiple logical variables that I can use in my conditional execution. And oftentimes I think it's easier to actually see this in action rather than to talk about it too much. So let's actually look at an example of how this would work in practice. And one of the things that I should say is in order to make this interesting, these decisions that you're using as your branch points are often going to be generated based upon user input or input from a sensor or input from instrumentation, or maybe even some result of processing data that you're kind of dragging in from a file. It's not like you're just going to make this decision arbitrarily, but this does have a lot of practical utility. And we can see a little bit of how it would work in this example. So imagine you wrote a MATLAB script to generate a random integer between minus 10 and 10, and you wanted each random integer to be generated with equal probability. So this is a uniform probability mass function, which you might remember back to last week, is implemented using the randi function. And then that's going to give us a random value that could be negative, it could be positive, or it could be 0. And what we want to do is use if statements in order to conditionally print whether the value is positive, negative, or zero. So if you notice, there's three different kind of code blocks that we may wish to execute there, depending upon the actual value that's generated by the function randi. So if you don't remember, you can just type help randi and kind of scroll up and look at some example code. That's the easiest way to do it. And you see that if you want to specify the minimum and maximum integer, which is generated by the function, you use this form. So usually I would just copy it right from the help file. I'll put some values in here to kind of make sure that it works the way I want it to work. Remember, after the first argument, that's where you actually put the size of the vector that you want the random number generator to return. So I won't pass anything in there since I just want a single number. And if I execute that a few times, you see that it's working exactly as we thought it would. It's returning a random number between -10 and 10. So I'm going to build my code just based upon that syntax, but I'm going to give the actual variable that's being returned an actual meaningful label. In addition, if I want to make good programming practice here, I might define my maximum and minimum values as variables. That way, if I want to change them later on, I can just change the variable value rather than changing the value inside the function call. So it just makes the code more readable. So if you want, you can put a little bit of a comment up at the top here. So let me see if I can zoom in on that. Good. So I'm going to put a comment, generate a random value, particularly a random integer between -10 and 10, and then we want to print whether it's positive, negative, or 0. So we've established a min value, the max value, and then we generate a random value. In general, you would want to suppress that output. So we can, usually good practice, I'm going to take and just copy all the code with the output of randval not suppressed. That way I can just make sure that everything's running correctly. So usually when I write code, this is exactly what I do. And it's generating a random value that's between -10 and 10. Looks good. Now what do I want to do? Well, there are three code blocks that I might want to execute conditionally. I might want to print the word positive to the screen if the random value is positive, negative if it's negative, and 0 if it's 0. So if you think about whenever you have three different code blocks that you want to execute conditionally, the format that you want to use, I should say this is one way to do the problem. This is kind of the cleanest way, in my opinion, is to use an if, else type statement. So what are we going to do? Well, we can pick any order that we want here, but you could say, let me just show you one approach to do it. You could evaluate initially if the random value is greater than 0. And you can put a little comma here and just say if it's positive. And what would you want to do conditionally? Remember, you don't have to tab in, but it's good practice to do that. Well, you just want to print the string positive to the command window. And remember, you do that with the display function. So we'll say if it's positive, print positive. Else if, what do we want to do? Well, if it's negative, and you can have an additional space there, but I think it's easier to read. And remember, you don't put a semicolon to terminate the actual logical values within your if, else statements. So we'll say if it's negative, and then I'm just going to copy all this, and probably would have been quicker just to retype it from scratch, but that's okay. We will print negative in this case. Now, do we actually have to give a condition under which we would print not negative, but 0? Well, if you think about it, we actually don't have to, because if a value is not positive or negative, it's definitely going to be 0. So I will just call this our lecture 6 example. And if I run it now, and one thing you'll notice is when you debug this, if you run it, you really can't tell whether it's working or not without being able to see what the random value is. So I'm going to take that semicolon away in order to not suppress the output, and I'll rerun this and see if it's running correctly. Notice that when the random value is 3, it's displaying positive. When the random value is -2, it's displaying negative. -6, negative. 9, positive. So the only case we haven't seen so far is the 0. It should ideally have to run it 10 times to see the 0, but remember, small sample effects, it might take a while. There it was. We see that when the random value was 0, it printed 0. So everything is doing correct here. And if you notice, MATLAB is actually giving me a recommendation that I could use a more kind of recent version of a function in order to display to the command window. And you might want to look into that and see exactly what the advantages are. Oftentimes it's just because older functions are deprecated and display is an older function within MATLAB. So notice, and sometimes it's just fun to change it and see, make sure it still works the same way. So let's save this. We know the kind of logic is working correctly, so I can suppress the output of rand val with a semicolon. And let's re-execute. And we notice, as we would expect, the DISP function works the same way as the display function, as is often the case when you have a deprecated function. They make it what's known as backwards compatible. So hopefully that was valuable to you in seeing the basics of conditional execution, along with the basic syntax of if else statements in MATLAB. If you only have one code block that you want to execute conditionally, just use an if statement. If you have two, use if else statement. And if you have three, use if else. And you can't have multiple else ifs in there if you have more than three that you need to execute. So you might have, anyways, that's enough on that. You'll see when we get to these kind of more advanced concepts in programming, it's kind of one of these things. I'll do my best to teach you them, but you got to play with some different coding examples, which we're going to have a chance to do. If you look at the structure of this course within the catalog on Alamo Colleges, you'll actually see that if you were taking it in person, we'd be a lot more lab heavy, which means that you would just be given coding assignments and I would kind of walk around and check that everything was working correctly and helping you debug. So we're kind of going to be transitioning more to that as we get towards the end of the course. The lecture will be a little bit light, and the real challenge will be trying to write your own code and get through the debugging process. So probably in addition to some kind of array and matrix operations at the end of this week's lecture that I mentioned in the previous lecture, we'll look at the basics of debugging. That way we can actually move to more sophisticated coding examples in the next couple of weeks.